Hello everyone, this is Dr. Webb. It's been one hell of a spring break, hasn't it? So in this video, I want to do a recap of all the things we've done since the last test a long time ago. Get us ready to move on. So all of this, we're focusing in on the derivative, which we're going to be using this limit definition where delta x, so we're thinking about delta x as being, this is talking about the change in x. That's in the denominator. And up in the numerator we have f of x plus delta x minus f of x. And so we can think about that as being the change in the function. So we'll call that delta f sometimes. And so if you think about what's going on inside this limit, deep down it's a slope. It's an average rate of change. We're taking the limit as the change in x goes to 0, and that's what's going to give us our derivative. Remember, the derivative is talking about the instantaneous rate of change of a function. It's talking about the slope of the tangent line, so the slope of the function at that point x. Some other notation that's sometimes used for this, we have f prime of x, which we'll use quite a bit. That's a whole lot easier to write than d dx of f of x. Sometimes, other times, we might use df dx, dy dx. These both mean the same thing as that. They're just shorthand for that. Another piece of notation, which I am not going to use, but you might see in some places, is just this capital D of f, which kind of means, you can think of it as saying take the derivative of f. So here's some derivatives we've already calculated. If we take the derivative of just x by itself, we get 1, and this should make a lot of sense, right? So if we think about y equals x, it's a line. What's the slope of it? Well, its slope is 1. If we take the derivative of x squared, we end up with 2x. So if we think about, what's the slope of x squared at x equals 2, and so if f of x is x squared, we want to know what's the slope of the function at x equals 2. Well, that's going to be 2 times 2, which is 4. And that's something we've done quite a bit in class. Finally, if we take derivative of just a constant, well, if we think about what the graph of y equals a constant is, this is just a horizontal line. What's the slope of a horizontal line? Its slope is 0. So, go back through how we figured these out. Let's calculate the derivative of 1 over x. So I'm going to be using this limit definition, right? So we're going to be looking at the limit of delta x goes to 0, and now we got to plug in where everything goes, right? So we have our delta x on the bottom. On the top here, that is our x of delta x, right? The x down here has been replaced with x plus delta x on the bottom, and then minus our function, minus 1 of minus x. And so now if we're looking at this, let me clear this stuff up. So this is the limit we're trying to do. If we notice, we've got fractions inside of fractions, so that's pretty annoying. So we want to clear the fractions on top. So to do that, we're going to multiply by the common denominator. So we need to clear out the first fraction. So x plus delta x times this is going to clear out this first one. And then I also need to clear out the second denominator. That's x. So this is what I need to multiply on top to clear both of those out. And then if I'm multiplying that on top, I've got to do the same thing to the bottom. So we're going to multiply this to both the top and bottom. And when we do that, back, you can see this x plus delta x. This is going to cancel off this and leave an x up on top. On the other hand, for the minus 1 over x term, that's going to cancel out the x's and leave the x plus delta x up on top. We're going to end up with this. So here, this is, that x is coming from x plus delta x over x plus delta x. So those two canceled off. And something similar is happening in that term right there. Okay. And notice that we have it showing up here on the bottom. That's important. If we left that out, things are not going to work. So now what can we do? Well, so if we look at what we have, let me change colors. Well, we've got an x right here. We've got a minus x right there. So they're going to cancel each other off. All that we're going to be left with on top is going to be delta x. And so we have minus sign carrying through. We have delta x on top, minus delta x on top, and then delta x times our old common denominator on the bottom. Going through, everything on the bottom is multiplied by delta x. There's a delta x on top. They're going to cancel each other off, and the top's going to turn into minus 1. So working out, that's our next line. Now when we look at this, in the denominator, we've got 1 delta x still, but it's inside this term, and so we don't have any problem setting this to 0 anymore. So we can go and swap that out with 0. We're left with minus 1 over x plus 0 times x. Well, x plus 0 times x, that's just going to be x squared. So what did we end up with at the end? 1 over x is, the derivative of 1 over x is minus 1 over x squared. Okay, so here's some basic derivative rules that we talked about right before spring break. So one, if you take a derivative of, so here this is a constant times a function, well, what happens? You can just pull that constant out. And so you pull the constant out, then you're just taking the derivative of the function. So it's the constant times the derivative. So anytime you have a constant times everything in a derivative, you can just pull that constant out. If we want to take the derivative of a sum of two things, well, it's just sum of the derivatives. So derivative of a sum is equal to sum of derivatives. And last but not least, what we worked on last class before spring break is we looked at the power rule. So it would be nice if when we took the derivative of a product, it was just the product of the derivatives, but it's not that, right? And so when you're taking the derivative of two functions times each other, what you end up with is derivative of the first times the second plus the first one times the derivative of the second. Right. So this is something you just got to remember. So let's see how this works in action. So let's think about taking the derivative of x squared. I know we already did this doing with the limits, but let's look at this doing this as using the product rule. So we can think about this as being derivative of x times x. And so in doing this, I can think about my f function being x, my g function being x as well. And so I have f is equal to x, g is equal to x. The derivative of x is 1. Same thing here, derivative of x is 1. And so then the product rule says this is going to be equal to f prime g plus fg prime. So looking at this, f prime is 1 times g is x plus f is x times g prime is 1. So we end up with x plus x, which gives us 2x. Right. And important thing to note when we're doing this, if you think about this f prime g, well, if we write it out like this, that's taking the product of that diagonal. And then for the second term, f times g prime, well, that's really taking the product of that diagonal. Right? So in the product rule, if we write it out in this nice little grid, f of f prime g over g prime, well, then the first term is one diagonal, the other term is the second diagonal. Okay, and so we ended up with exactly what we knew before, that the derivative of x squared equals 2x. Then we can do the same thing, say if we wanted to take the derivative of x cubed. So we can think about this as being x times x squared. So I can let my f function be x, my g function be x squared, f prime is going to be 1, g prime, we've got g prime right there, that's going to be 2x, and so when we're using the product rule, f prime g plus fg prime, f prime g is going to give me 1 times x squared plus fg prime is going to be x times 2x. So this is really 2x squared, so I have x squared plus 2x squared is going to give me 3x squared. And so that's what we end up with. And one thing to note, when we're looking at both of these derivatives, well, here I have x squared, and then I end up with 2x. So it's kind of like that power came down, and then the power of x up here is 1 less. So x to the 2 minus 1. And the same thing happens here for x cubed, right? So my power, I started off with 3. What happened to that 3? Well, it came down. I ended up with 3x squared, with 3. And then my new power here, 2, I can think about 2 as being 3 minus 1. Works in general, and we'll see more about that later. And so this kind of trick, what if we wanted to do something like taking the derivative of 1 over x squared? Well, we did derivative of 1 over x before, so we can use the product rule again. So I can think about this as being d dx of 1 over x times 1 over x. So my f is 1 over x, my g is 1 over x. And then we worked out the derivative of 1 over x before. If you don't remember, you can pause right now, scroll back and see what that was. Or I can just tell you right now. And it's minus 1 over x squared. Minus 1 over x squared. And so f prime g plus fg prime is our product rule. And so f prime g minus 1 over x squared times 1 over x is 1 over x squared times 1 over x, that's multiplication, plus other diagonal looks the same, 1 over x times minus 1 over x squared. So that's going to give me minus 1 over x cubed. That's coming from that guy. This guy's going to give me another one of those. I like these colors. Minus 1 over x cubed. And so at the end we have 2, minus 2 over x cubed. And so that's our answer. If we do the same thing with, we can do the same sort of thing with 1 over x cubed. So we can think about this as being 1 over x squared times 1 over x. So my f here, 1 over x squared, my g is 1 over x, say. Derivative of 1 over x squared, I got it right here. So it's minus 2 over x cubed. Derivative of g, minus 1 over x squared. So when we use the product rule, f prime g plus fg prime, f prime is minus 2 over x cubed times g is 1 over x. My fg prime is sitting right up there. So I have 1 over x squared times minus 1 over x squared. And so this is minus 2 over x to the fourth plus minus 1 over x to the fourth. And so what do we end up with? Minus 3 over x to the fourth. And so that's what we end up with. And so if you look at both of these, well, we can think about 1 over x squared as being the same thing as x to the minus 2. Well, what did we get for the derivative? Well, that minus 2 pulled out. So we get the minus 2 pulling out. And then we have x to the minus 2. If we subtract one more from that, we get minus 3. So this is minus 2 over, that's not what I wanted to write. Minus 2 over x to the minus 3. So same sort of thing that we saw before with the positive powers of x. Same idea over here. We can think about 1 over x cubed as being x to the minus 3. And so we're going to pull the minus 3 out, decrease our power by 1. And so we end up with minus 3 times x to the minus 4. And that's the same thing that we got. And so this leads us to what we call the power rule. And so if we think about, we're just taking the derivative of x to the power. Well, same thing that we saw is going to happen. We're going to take the power comes down, and so we're going to end up with n, and then the new power we get for x is we subtract 1 from that. So x to the n minus 1. And as we saw, this works for both positive and negative powers. Okay, so that's the power rule. Finish this off, I wanted to give you a couple of practice problems you can work on. So first one, taking the derivative of this function here, so you can see basically it's a bunch of things with constants, powers of x with constants added together. So you can use, idea of the sum of derivatives is the derivative of a sum is the sum of the derivatives. Help you through on this one. So here we've got a quadratic times a linear function. And so there's really two different ways you could go about this. So one way is you could just multiply them together first. That's the idea of expanding first, and then take the derivatives, very much similar to the first one. Or, since we're thinking, the way we have it written right now is two functions multiplied together, and so you could take the derivative using the product rule. So it might actually be, a good idea to try out both of them. and see what you get from each one and make sure that they're deep down what you end up with is really the same. And finally, we've got 3x squared minus 4 divided by x. So how can you think about this one as a product rule? You know, what are the two functions here that are getting multiplied together? So that's all for this video. I hope you all are doing well, and I hope to see you soon.